I'm Liz Beckman. Welcome to this part of the CT at 50 celebration. This is a brief introduction to the original proposal for the development of a system which became the CT scanner. In October 1968, Godfrey Hounsfield submitted a proposal for a research project to his directors at the Central Research Laboratories at EMI Limited in London. While Godfrey Hounsfield had a lot of experience in computers, having designed the first British transistorized computer, he had no experience in medical systems. He had seen how radar had greatly helped World War II pilots to navigate far better, but he had limited formal education, and all his knowledge of physics, electronics, and even mathematics was largely self-taught. Here you can see the cover page of Godfrey's own copy of the project proposal, where he has handwritten his own name on the page. The introduction of the project clearly states that he is proposing to investigate the use of the computer to make much better use of the information obtained when an object is examined by gamma rays or by X-rays. While you can see on the right that the page of the description of the system is heavily annotated by Godfrey, this is actually very close to the final version of the project proposal. The image on the left clearly shows the principle of having a source on one side of the body. He's already changed it to be an X-ray source, and on the other side a detector, and he is already at this stage showing his proposal to create images as individual slices through the body and how each slice would cut through at a different level, through a tumour or through the bone. Even at this early stage of his proposal, Hounsfield was already showing incredible understanding of CT and of its benefits. No one, including Godfrey, had ever seen a CT scan or anything like it. But he had already worked out that the system would be able to detect tumours by calculating the absorption value of the tumour, and that this meant that lower spatial resolution could be accepted. He had also proposed that the system would make much better utilisation of the information for a given dose, and also that it would not suffer from the classic superimposition of classical X-rays. So, as well as recognising the benefit of overcoming superimposition and gaining the ability of accurate absorption values, Hounsfield at this early stage proposed the use of windowing to display the full range of grayscales over the key absorption values of interest. The project proposal was peer-reviewed by Frank Doyle, who had several meetings with Godfrey. Frank Doyle was concerned by many aspects, especially those of heterogeneous X-rays, that is, the spectrum of the X-rays in terms of photon energy and what we might call beam hardening. Doyle recorded that any concerns he raised, Godfrey had already thought about, and was a knight's move ahead of him at every turn. Doyle concluded that the project was worth backing. In the proposal, Hounsfield compared the performance that he predicted from his proposed system to that achievable at the time from conventional X-ray and linear tomography systems. He highlighted the fact that while the minimum definition predicted from the proposed system was less than that achievable on the normal X-ray, his proposed system would have the ability to deduce the absolute value of absorption of a cubic centimetre, in other words, a voxel, while it was impossible to deduce this absorption value in a classic X-ray image. He also stated that it would be theoretically possible to generate a set of between 20 and 40 pictures from one radiation dose on his system, compared to the one picture from a conventional X-ray. While these drawings are not actually from the original proposal, they are diagrams from Hounsfield from that period around 1968 and illustrate his thought process of how to image a three-dimensional object by considering it as a series of slices and by taking readings from all angles around the three-dimensional object to reconstruct images of those slices. Again, this diagram is not from the original proposal, but is from one of Godfrey Hounsfield's early notebooks of the period, and clearly illustrates his plans to consider a scanner for the whole body, not purely for the head. But he was guided to initially concentrate and focus on the imaging of the brain. It's also incredible that Hounsfield foresaw that once CT was proven using the components that existed at the time, then new components such as detectors, electronics, X-ray tubes and computers would be developed that would enable great improvements in the system, such as here where we can see a bank of detectors suitable for cone beam scanning. It's incredible to realise just what Godfrey Hounsfield achieved in the design and development of the CT scanner, particularly with so little formal education, and after being labelled as intellectually retarded in one of his school reports. It is also stunning to realise just how much of the modern-day CT scanner was considered and described by Godfrey Hounsfield in his original project proposal. Thank you for watching this brief introduction to the original 1968 project proposal as part of the celebration of CT at 50.